Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ETC department and we are discussing the subject data structures 2. And yesterday we have talked about the binary search trees and we have talked about that. In today's lecture we're going to see the algorithms for searching, inserting and deleting a node from a binary search tree. But before going on to that, let me first get back to you to the tree traversals, that is binary tree traversals. Okay, by traversing I means what are the approaches, how you are going to visit each of the nodes in your binary trees. Okay. So in today's lecture, we are not going to visit the algorithms for searching, deletion and insertion in a BST, but we are going to see the traversals because they are essential for moving ahead. So let's get back to the nodes and then we will see a particular example for that. So traversal is a process to visit all the nodes of a tree and may print their values too. Because all the nodes are connected via edges, that is links, we always start from the root node. That is, we cannot randomly access a node in a tree. Now there are three ways which we use to traverse a tree. The first is in order, second one is pre-order, and the third one is post-order. Okay. Generally, we traverse a tree to search or locate a given item or key in a tree or to print all the values it contains. Let us first see your in-order traversal. Now in this traversal method, the left subtree is visited first, then the root, that is the parent of that, and later the right subtree is visited. Now we should always remember that every node may represent a subtree itself. So we have to get down to it. So you can say this particular type of traversals are actually recursive in action. Okay, we'll see that in a minute. Now if a binary tree is traversed in order, the output will produce sorted keys values in an ascending order. Why in ascending order? Because if we specifically talk about your binary search tree, that is your BST, we know that the smallest of the values are actually coupled to the leftmost side of the tree. And because in the in order we always start from the leftmost node, so you can say that smallest of the values in your BST will be traversed first, then the middle ones, and then to the far right, the largest ones. So in a way, when you have traversed through all the complete tree, the array that you are going to see of the values of the nodes of the tree is in ascending order itself. So it's kind of sorting. Okay, now binary search tree is actually a sorted tree itself, because we have placed every node not by randomly or by the event of their insertion or the occurrence of their insertion, but we have calculated their place effectively by choosing the value or by comparison of the value to be inserted with the subsequent nodes, that is first, then that is the roots at the subsequent levels, or not the root but the parents at the subsequent levels. Okay, so that is why if you talk about your binary search tree and if you apply your in order traversal to it, you will see that the array that you are going to end up with is actually a sorted array with ascending values. Okay, so let's start with in order traversal. The only rule for in order traversal is that you have to visit your left let's say subtree first, then the node, and then the right. So the name that is in order, the in means that root is going to be inside between left and right. Okay, And same way, pre-order means that your route is going to be before is going to be traversed before any of the let's say other node. And for the post order means, sorry, for the post order means your route is going to be traversed at the end. Okay, so I think you have got the point what I'm trying to say here. This in, pre, and post is actually meant for your parent at any point. Okay, so your parent, what is the position of your parent in the rule of traversal decides the name of it. So for in, it is between the right and left. For pre, it is before right or left, and in the post, it is after right or left. Okay, so I think you have got the point. So let's see, for this particular example, we are going to see one more example, how we are going to achieve the in order traversal. Now for in order traversal, first you have to look out for your leftmost route, leftmost node. So our leftmost node is D. So D is going to be inserted in the array first, or you are going to start with D. Now after that, now there's a line in the starting which we should focus on, that all the nodes are connected via edges and links, and we always start from the node. And here we are actually starting from the leftmost, but algorithmically or by the rule of coding, we are not going to do that. What we are going to do that is we first apply your in order at this particular tree. That is, we first collapse this particular tree into one node and this particular subtree in one node. That is why I have mentioned a triangle there. So suppose this particular tree has only 3 nodes, that is 1, 2, and 3. Okay, keep this particular left subtree as 1, or you can assume this particular right tree subtree as 1 subtree. Okay, now if we try to traverse in this particular tree, that is with node 1, 2, and 3 via the in order rule, first we will get to the root but will not fetch it. First we'll read the first subtree, because the rule says first you have to traverse or look out for your left child first. Okay, so we are at the left child, but the left child came out to be a subtree in itself. It is not a single node, it is a subtree in itself. So again, now here this is the call for recursion. Recursively, it will again push out for the left child of this particular subtree. So B is not going to be read first. We'll look for the left child of this particular node, that is D. So that is why this particular subtree is also written here as 1, 2, and 3. So first we'll apply in order to this particular subtree, that is the larger one. Then after arriving to the left child, we have to look if it has a child or not. If it is child, then again we have to look for the left child. Okay, so that is how we are going to proceed in this particular. So there is going to be a recursive call, and the recursive calls will proceed or will go on until and unless the we have reached to the leaves. Okay, let's start with it, how to deal with it. So the algorithm will first look for the left child of this particular node, that is root node A. It's going to be inside this particular subtree. Now when it reaches there, it will find out that this particular tree is also not a single node, is also a subtree in itself. So when it reaches there, it is going to look for the left subchild of this particular node B, and it has now got to the D. It will again look for its child. It will not found. So it has been declared that the node D is a leaf node itself. So the first node that is being traversed will be the D. And after the D, as the rule says, first the left, then the parent, and then the right. Okay, so we are done with the left subchild, then the root, that is B, and then E. Okay, now the rule says you have to go to D. Okay, I think I am in the wrong one. Yeah, okay, sorry. I'm in the wrong one. Okay, so first D, then B, and then E. Now we are done with this particular child. We are done traversing the left child of the root A. So that is why we have written the sequence here. That is, first the D will be traversed, that is the left. Then B is traversed, that is the root in this particular subtree only. I'm talking about this particular root, or you can say parent, and then the right child, that is E. Now we are done with this particular parent here. This particular child here, that is the left subtree here. Now we are going to traverse to the root of this, that is A. That is why A has been mentioned. After that, we are going to get into this right hand side of subtree. Now this right hand side subtree is not only a single child but a subtree itself. So again, the in order will be applied. The in order will say that we have to look for the leftmost child first. Now the leftmost child is F, that is why F has been traversed first, then the parent, that is C, and then in the end the rightmost, that is G. Okay, so this is how you are going to traverse or solve your traversal problem using in order traversal. Okay, so recursively, the algorithm says that step 1, recursively traverse to the left subtree, visit the root node, recursively traverse to the right subtree. Now that is what we have done here. We have looked for the child of A, which is this particular subtree, and inside this particular subtree again in order will be applied, that is a recursive call, and it will look for left child of B, which is D. Now D doesn't have any child, so it will stop there and start traversing. After D, the parent will be traversed, that is B, and then after B, the right child will be traversed, that is E. Now we are done with the left part of or the left children of A, which is the root node. Now we'll proceed to the A. After traversal of A, we'll go to the right hand side. Again, in the right hand side, we have to look if it is a single node or a subtree. So again, it will look for F, and then C, and then G. Okay, so one more example. Let's take one more example. In this case, as you can see, the in order traversal will be, first we'll start with the root. Now according to the rule, we have to go to the leftmost child, which is 15th. Now 15 is not a single node, it is a subtree. Again, look for the left. One more recursive call. Now 10 is again not a single node, we have to look again for the left, that is 4. Now 4 will be traversed first. Now look at this particular sequence here. I have a sequence. You can pause your video here and try to solve this particular problem without looking at the answer, based on the assumption that we have made or the example we have taken in the notes. Okay, try to solve this particular problem without looking to the notes. Okay, or you can take help of the notes, but don't look at this sequence first. Try to solve it first and then try to match it with your own answer. Okay, so I think my answer will go as the 4 will be traversed first, and then 10, and then 12, and after that is going to be 15, and then we'll go here, but it will not be traversed first the leftmost, that is 18, then 22, and then 24. Now we are done with the left part. Then after 25, then we'll go here, but we'll not look for it because we have to go to the left child. Left child is 35. 35 is not a single node, it is a subtree. Again we'll go to 31st. So 31st is going to be traversed next, then 35, then 44. We are done with the left. Then 50, then we'll go to 70. 70 will not be traversed at this time because we have to go to the left. 66 is going to be traversed first, then 70, and then 90. Okay, I think we have followed this particular order here. You can match your answer with with this particular order here. Now this is your in order traversal array. As you can see, it is a sorted one with ascending values. Okay, so this is what we have stated in the first place. Now let's get back to the next one, that is your preorder traversal. Now in preorder traversal, the root node is visited first. That is the name pre, that is before left and right. The left subtree next, and finally the right hand side. So if you try to see that in this particular example, we start with the root. The rule says you have to traverse the root first, that is the parent first. So A will be traversed first. Then to the left hand side, we have to see, we have to go to the left hand side. Now, if left hand side is a single node, it will be traversed, but in this case, it is not. It is a left subtree. Again, we have to look for the root node first, or the parent of that. In this particular subtree, the root is B, then D, okay, and then E. Now we are done with the left. Now we have to proceed to the right, not to the root, because it has already been traversed. See, you can see this particular sequence here. The root first, A, then to the right hand side, to the left hand side subtree, again the root first, B, then the left, D, and then the right, E. Now we'll go to the right hand side of this particular root node A. Now inside this, again the root first, that is C, then the left, F, and then the right, G. And this is how you're going to traverse your binary tree using pre-order traversal. Now this is not going to be a sorted array, because we have not followed the actual rule, okay, of the binary search tree. That is, we have not looked for the smallest value first. We have looked for the root node first. Okay, so the array is not going to be sorted one. Again, get back to the example that I have shown you. I have also listed the pre-order traversal here and the post-order traversal here. All you have to do is just pause this video, look for your pre-order, try to write your pre-order traversal, and then try to match it with the answer that I have been provided here. Okay, so you must do that. Now let's get back to the notes and look for our last traversal. Now this is your post-order traversal. It means you have to look or traverse the root or the parent at the end. So how we are going to start is, first we traverse the left subtree, then the right subtree, and finally the root node. Okay, so I think A is going to be traversed in the last. So first we are going to the leftmost side. Now inside the left subtree, we are again going to look for the leftmost node, that is D, and as the rule says, we have to go to the right next, that is E, and after that at the end we have to look for its parent, that is B. So the sequence is D first, that is left, right, and root. So your post order traversal is left, right, root. Please keep that thing in mind. The placement of root with respect to left and right actually conveys you the name. So it is easy to remember which traversal rule belongs to which kind of traversal by just keeping in mind the post, pre, or inward in mind. These signifies the traversal, the traversing place of the root. So in this case, left, right, and the root. The root is last. So that is why post. Post means after left and right. So the D, E, B. After that, we are not going to traverse to the A first, because the rule says after left you have to go to the right hand side. So inside the right hand side again, first you have to go to the left, that is F, then to the right, that is G, and to the root C, and then to the end, the root of this particular tree, that is A. So this is what we have been what I have mentioned here, that is D, E, B, F, and then G, C, A. So this is how you are going to traverse through your binary tree using your post order traversal. I think you people have read this before in your few of the courses in your second year, but I have revised it for you again. Just try to solve some of the unsolved questions and try to match your answers with the correct answers given in your book and the example that I have mentioned in the other slide. Just pause your video there and try to solve. By getting the right answers for one particular example will make you understand the whole algorithm in itself. Okay, so it is not like you have to do 20 questions for a particular algorithm. All you have to do is take a good example and try to traverse it with all the three methods of travel. So that is in order, post order, and pre-order, and that will get you the idea what are those traversal algorithms actually are. Okay, so thank you.